Hello. In this video, we're going to start looking at the radical parent functions. So the first one we're going to look at is the square root function. So y equals the square root of x is the parent function for all square root functions. Now, or at least the ones that we're going to see in this class. Notice that our x's begin at 0, 1, 4, and 9 here. This is different from what we saw before because we need to look at the domain here. Looking at the domain, we realize that we have an even indexed radical, which means anything underneath the radical, in this case an x, must be greater than or equal to 0. So that tells me that the domain is going to be 0 to infinity. So the smallest number I can ever use is 0, which is the reason it begins at 0. Plug in the 0, square root of 0 gives us 0. Now the next number we have here is a 1, so plug in the 1, square root of 1 is 1. But the next number is not 2. The reason the next number is not 2 is because the square root of 2 is approximately 1.4 blah 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 blah. It's an irrational number. The square root of 3 is irrational as well. Square root of 4, however, is not irrational because it's a perfect square. So if we plug in the 4, square root of 4 gives us 2. And for the same reasoning, we don't continue or we don't write any other x's down until we get to number 9. And so plug in the 9, square root of 9 gives us 3. Excellent. Now, plug in or plot these points 0, 0, 1, 1, 4, 2, and 9, 3. 9, 3, notice it's technically off the edge here. And it would look approximately right there. I don't really care if you plot it or not, but just know that's about where it is. And this is what the function is going to look like. It's basically the quadratic on its side, just the top half. Also notice I do not put an arrow here at this edge because we do not continue going down or anything like that. It begins right here and goes to the right, and there's an arrow here because it continues to the right. Excellent. By the way, notice that the range here is 0 to infinity because this is pointing up and to the right. All right, so that's pretty much what you need to know about the square root function. Now, let's look at the cube root function. As for the cube root function, the domain is actually going to be all real numbers negative infinity to infinity because look at the index. The index is an odd value, and so therefore it's not one of the even indexed radicals. So the domain is just negative infinity to infinity. Looking at x values, we've chosen some interesting ones, but notice that all of these are perfect cubes, which is the reason we want these x values. Plugging in the negative 8 underneath the radical, the cube root of negative 8 is negative 2, because negative 2 cubed gives us negative 8. Plug in the negative 1, or cube root of negative 1 is negative 1 because negative 1 cubed is negative 1. Plug in the 0, you get 0. Plug in the 1, you get 1. And plug in the 8, you get 2. Outstanding. Graphing this, negative 8, negative 2 is right here. Negative 1, 0, 0, 1, 1, 2, 8. And then just connect these with a curve. Preferably a curve that doesn't look ridiculous. Close enough. Try to make it as smooth as possible. It's kind of hard too on the iPad here. There we go, that's better. Alrighty. By the way, notice that I do put arrows at both ends because this continues in both directions. The domain is negative infinity to infinity. Alrighty. Well, there are both radicals that we're going to be dealing with there. Notice that we don't continue on to the fourth root of x because, well, we just don't. But it'll look very similar to the square root, just a little bit sharper here and going a little bit shallower. Fifth root, same thing with the cube root, just sharper and shallower. and 6 through, and so on and so forth. Alrighty. Well, I believe that that's it for this particular video. I'm going to go ahead and end it here, and I will see you in the next one. Have fun.